There's no fire.
No fire.
Okay.
Just
I was misinformed. Not fireside.
What this is going to be a conversation about training and basically compute. And I just want to thank Mandeep for inviting me to do this. And he knows that a big story and a big priority for so many of you, if you are a founder of a company working on a large language model, you are the CEO, CFO, CTO of a very large enterprise company, you are one of the investors that's funding all of this, access to compute has been the story, and that's my experience of the last year. Setting the scene a bit, Brian, in terms of CoreWeave and what CoreWeave is, the way that I would put it is that you want to be the top provider of cloud-based computing away from the hyperscalers who also offer similar things. But how would you position CoreWeave?
So a little differently. We're not here to host those generalized type of workloads. We're specifically focused around AI, HPC style workloads, and we've built our cloud and our infrastructure.
Across training and inference.
Training and inference, or any other type of HPC application, whether it's batch processing. We've built our infrastructure specifically for that. We don't host CDNs. We don't do websites. We don't care about video transcoding. We're here to provide compute at scale.
And we are talking about the cutting edge of compute as well.
Yes. Unfortunately, I'm responsible for the cutting edge of compute.
When we say infrastructure, in layman's terms, what does that mean?
So, at the user level, they think about it as consuming servers on demand, but it's so much more than just the actual physical machines. It's the physical machines, the networking behind it, the storage attached to it, the east-west networking inside of the data center, the north-south networking out of the data center. It is the cooling infrastructure of the data center. It is power infrastructure. It's design of the data centers. It's even things like cable routing to the data centers and dealing with airflow considerations. Like, it is such a specialized package when I say infrastructure that a lot of people don't understand how physical the business is, right? And we just hosted a company offsite 2 weeks ago, and we do it once a year where everybody from the company comes, and we hosted it down in one of our new data centers in Richmond, Virginia. And the point of that is that I have hundreds of people that have been working for clouds for the last 10 years, and many of them have never been inside of a data center.
Why was that important to you?
It was just so important because they have to see how physical our business is, right? That it's not just throw a server on a shelf, right? It's you put a server, you rack a server, you have whether it's 14 connections to network for that single server. It's the way that we deal with power cable routing. When we were building our first supercomputer with H100s for Inflection AI back in January, I actually moved to Las Vegas to be in one of our data centers for a month.
Is this like an Elon Musk sleeping on the production line floor equivalent?
He's way richer than I am. So no, and I hope that I'm less crazy.
You're not sleeping on the data center floors.
I didn't say that.
Okay.
So we had like the Silicon Valley house 5 minutes from the data center. We were there every day. And I walked in and went to my data center techs and I said, "Can I help?" And they were like, "Yeah, go run power cables." I'm like, "All right, cool. Like, I'm going to go do this." And like, one of the things that's always been important to me is like, I have to be willing to do the task I'm asking them to do. Right. And I'm standing there for 10 minutes and I'm running power cables and I thought I was doing a great job. And my head technician comes over and he's like, "You got to stop." I'm like, "What do you mean?"
You're causing more chaos than help?
No, and I was like, "I don't understand what happened." He's like, "You put the labels on the wrong way." And I'm like, "What do you mean the labels?" And he said, "You putting the labels on so it's going to block exhaust airflow, it's going to increase static pressure, and it's going to inhibit our cooling capabilities." And I was like, "Okay, I'm out." Right? And it was, a level of detail that I never thought of. But as we've built and scaled this business, like every little one of those things matters, right? And showing the company how physical the business was, what it takes to run those types of facilities, how big the facilities are, what the mechanical plant looks like, what can fail, just all the different things that go into it. It made them appreciate a lot more of like just how big this is and how complex it is.
Zoom out for me then. Just how big is it? How many data centers across the country, and where largely are they on the infrastructure side?
So publicly we have 3, but we have 18. Okay, it's fine. I said it. It's on the record. From a total power capacity perspective, I believe the number is like 340 megawatts at this point.
Okay, wow.
And there is another couple hundred megawatts in the pipeline. They're typically, anything that we're signing today is typically going to be 18 megawatts or larger, right? When you think about...
Which has a substantive impact on the localized grid of wherever you're putting that.
Yes. For this workload type, for training infrastructure in particular, it has a very big impact. And to dig into that a little bit, for a regular data center workload, you're going to have some cyclicality on a daily basis that goes up and down with time of day and what your users are doing, and it may run a little bit hotter during the day and colder at night. For AI workloads, it is very much an all or nothing load scenario.
Either they're running the workload for like months, or they're not doing anything at all.
And it's not even just the longer period of time, it's even within a day. And what that means is that the workload could be running for, let's call it 12 hours, and then if you have a cluster that has 120,000 different InfiniBand connections to handle the east-west GPU traffic, and that's allowing GPUs to communicate to each other. If one of those links flap, like the entire job stops.
Give me 1 second. Let's set a baseline because we have 30 minutes left to go in this conversation. I don't want to go too far. Hands up if you've ever heard of H100. Okay, good. Phew. Okay. So what we're talking about for idiots like me is an AI accelerator at a basic level, or more commonly known as a GPU. The GPU is not a chip that you can hold in your hand. It goes into a...
I can hold them in my hand.
I've actually held one in my hand as well. Shameless plug, but I did a fantastic piece on the H100. Go out and find it. But it goes into DGX server design. The server design goes in with many others into massive data centers, and you can count them as nodes in the thousands in some cases, right? But that is the scale of what we're talking about here.
Correct.
But as you and I were talking about backstage, H100 is like a badge of honor for so many companies out there that are building some sort of AI tool or the foundational large language model that goes with it. I think it's a good point to ask, what is your relationship with NVIDIA then? CoreWeave's relationship to NVIDIA and how you use the H100?
So, tough question. We are, I'd say, partners with NVIDIA, right? And partners in the way that we are a customer of theirs.
Right.
They work with us on custom solutions and help us serve our clients. They were an investor in one of our equity rounds earlier this year. But at the end of the day, I'm just like everybody else. When I buy infrastructure, I get in line. I tell them I want it this time next year. They tell me yes or no. And I'm kind of like everybody else in the pipeline that waits. Like,
I want to get to the supply issue in a little bit. I would say there's a tight market for the supply of AI accelerators. But there are some case studies and you mentioned one of them that maybe we can talk through that will explain to everyone that relationship. So the first publicly announced sort of customer who ran a workload backed by capacity using H100s was Novel AI. Chronologically, there was one other name that went before that, I think Inflection AI. But just explain those two in any order that you like.
Sure. So we'll focus primarily on Inflection.
Okay.
We were tasked by Inflection late last year with building them their first H100 cluster, and their message to us was, we want to go fast, right? And we want to go fast at scale, like now. Like fast means now.
And the pressure from them was that they wanted to train a next generation model or support the inference side of their existing work.
It was to train a new model.
Okay.
Okay. We explained to them that this was a brand new architecture, that there were going to be problems, and they said, we know the risk is worth it for us. Like, we want to go fast. And we started bringing up their environment in February of this year. That was actually the cluster that was used for MLPerf, which is like the Olympics of compute. back in April that CoreWeave and NVIDIA submitted together. But that cluster has thousands of GPUs. It's based out of our Las Vegas data center, and it was the first cluster that we've done with them. We're also in the process of doing a second cluster with them that's considerably larger. But it was early on. Whenever you have an architecture that changes so much as H100 did from the previous A100 generation, it moved from PCIe Gen 4 to PCIe Gen 5. It introduced a new InfiniBand standard. It introduced a new way that InfiniBand actually got cabled. It was,
And in simple terms, InfiniBand is an interconnector that combines many different units of the server design.
Correct.
Yeah.
It allows all the GPUs to communicate with each other. And there were just so many things that changed from the previous generation that a lot of stuff was going to go wrong, and a lot of things went wrong. But the partnership there was okay. It was their team, it was our team, and we were going back to NVIDIA and working. Okay, this is what happened. This is what we believe the root cause to be. How do we work around it for now, and then how do we solve the problem down the road? And I think that that partnership was incredibly important to actually getting H100 stable for the entire industry, right? We were finding problems all over the place, right? And it was just how quickly can you work them out and how quickly can you move on?
This conversation is training challenges in GPUs,
Yes.
challenges in compute. And I guess you come at this from CoreWeave's perspective, but I think it's fair to say that broadly speaking, H100 is viewed as the best AI accelerator. If you are building and then training a large language model in the billions or many tens of billions of parameters, can you explain why building your infrastructure with H100 is the right way to go? So is it the only way to go?
Yeah, I'm not going to be so arrogant to say it's the only way to go. I think that when you think through what is the best solution, it's not just hardware, right? And while I believe that NVIDIA has the best hardware and the H100 is the best accelerator today, it's also about the ecosystem, right? And how expensive is it to port from an H100 or from the CUDA stack to go to TPUs to run it on jacks or whatever, right? That's time that's so incredibly valuable for an AI startup, right? When they're typically going to be most resource constrained with the people that would have to go do that, right? Am I going to worry about time to market, or am I going to worry about saving 5% on something that may take me 4 months to go port over to, right? So, NVIDIA is in this crazy position where they have the best hardware, but they also invested so heavily in this ecosystem for the past 10 years, building out all this open source software, building the products and the tools that people use. And, if you're starting an AI company today, you want to be able to leverage that 10 years of work that other people have done before you to accelerate your progress. And so I think it's going to be very hard for anybody to really kind of upseat the king, right? And it's not just because they have the best hardware, it's because they have the best all-in AI kind of ecosystem.
I want to get on to kind of the future and growth soon for CoreWeave, and then and a slightly more sort of philosophical question, but just very quickly, there are other GPUs on paper that are coming. Gaudi from Intel. They're all slightly different combinations of GPU, CPU. They have different at their design generations and proportions of high bandwidth memory, and that goes kind of down the specialized silicon conversation, which we're not here to do. But is it possible in the future that you build infrastructure with an MI300X from AMD, or work on a server design with Intel? How rigid is your ability to do that or not?
We have no plans to do that today, right? I mean,
I am talking sort of hypothetically and academically.
Hypothetically, I can do whatever I want, but we're going to choose the best platform, and that is the NVIDIA platform today.
Okay, so we're starting.
Loaded question, man.
I am a Bloomberg journalist, sir. We'll set another baseline, which is right now there is an awful lot of demand out there for compute capacity, cloud-based compute capacity in particular, and therefore you plan to expand your infrastructure. because the demand is such that you need to do it quickly?
We're typically faced with customers that come to us, or potential customers that come to us and say, hey, I want to do XYZ and I want it next week. And XYZ is typically, I want a supercomputer that's 35,000 GPUs, and it has to be done this way, and I need it now. And you know, this movement and what's happened in this market has taken everybody by storm.
You mean in the context of 2023, basically?
Yeah, nobody was ready for this. Nobody last year at this time would have said, okay, this is what I think AI success is going to look like. Like when ChatGPT was launched, you know, it was one of those things like, okay, like this is kind of crazy. This is getting real. But did I think, like, we had $100 million in sales forecasted for this year, and that was like our stretch goal. Like, if I said it, I get yelled at. But it's orders of magnitude larger than that.
I knew you'd say that.
And
such an Elon Musk-ism. Orders of magnitude. What does that even mean?
Okay, it's more than 100x that. Okay.
Yeah, shout it out. I mean,
I didn't
take
say
the pressure
it.
off me.
I didn't say it. So,
you know,
it's
please.
Like that wasn't the plan, right? Like,
and was ChatGPT the starter gun for that?
Yeah, it was that. Like we had already committed to buy what we thought was a crazy amount of H100s, which was like $100 million worth. It was like 2,800 GPUs, and that's like so cute now, right? And we had put the business but the business was basically at risk. And you know, I'm actually going to drinks with after this with one of the guys from Magnetars, one of our long-term investors.
Yes.
And earlier this year, he said, I remember the day we went to dinner in Chicago and we flew out there. And he was like, you were literally banging on the table that you had to do this. And it was business defining for the company to actually own H100s at day
we're
zero.
We're talking about literally 2,800, 2,800.
Yes, 2,800. And
he's like, meh, that's nothing.
Literally. If we don't have that done, like we installed 2,800 of them yesterday. Literally in one day. And like he was like, you were so convinced, and we thought you were crazy, but we gave you the money anyway. And he's like, and you were somehow right. And I'm like, I had no idea. Like I had no idea it was going to be what's happened. And you know, every time I turn around and I think that demand is starting to soften, somebody else with some new idea or new technology or some new source of capital comes at us, right? And the growth is just, it's relentless.
Well, let's get to the capital in a minute. What I always think about, no one will let me in a data center, by the way.
Is that a request?
No, I'm just saying, no one's ever said come in and take a look. But from the outside,
take a look.
Thank you.
We're happy to have you.
They're ginormous. The energy consumption is incredible. And there's a space commitment. There's also, you know, resources like water, which many people don't think about. It just explained the challenge of those infrastructure projects if you were to build more data centers.
Yeah, so 6 weeks ago, our plan of record was that we were going to be deploying the next 2 generations of infrastructure, still air-cooled. And today, we're 6 weeks away from our first liquid-directed chip environment. Right? Okay. So in 2 months or 2.5 months, we've completely changed our cooling story about what we're going to be doing for all of our expansions.
What's the advantage of liquid-cooled versus air-cooled?
You know, it's uniformity and temperature of the environment, but that's for the hardware. It's PUE, so it's energy efficiency inside of the data center. You know, it's a lot harder to operationalize, right? But from a cost and efficiency and environmental perspective, like it is much better for us. You know, we were very focused on scaling earlier this year, and you know that easiest path to scale was air cooling, right? Any data center can handle it. But when we were signing leases and data center contracts, it was always okay. How long are we signing this lease for? If it doesn't have a chilled water loop, if it doesn't have water and we can't do this later down the road, sign a shorter lease. If it has what we need and it's a really good facility, sign a 15-year lease.
That literally requires a reservoir, or what's the...
So it requires chilled water plants, you know, access to potable water from the local municipality, you know, thermal reserve tanks, because if the chiller plants are typically, and this is getting way into the details, but you lose power. Your data center doesn't lose power, but your chiller plant loses power, and it's not backed up by UPS, or it is backed up by generation, but it goes down. It takes 20 minutes to restart, and the data center starts on fire. So you know they have thermal water tanks to make sure that you can hold over during these periods. Like it's a very complex system, right? And we were trying to be forward-looking in what we were signing longer contracts to, but we thought it was going to happen in 2 years, and now it's today.
I actually think there's a lot of value in explaining the reality of what you're trying to build. Let's bring it back to the context of generative AI. Companies come to you and say, we want to train a large model. We started with the generations of GPT that were in the tens of billions of parameters, Llama 2 being another example of that, what Elon's done with Grok 1. But there are also loads out there building models with a few billion parameters, a different scale. The point is that right now they all want the same thing, which is access to the compute. Look into the future and tell me, is there actually enough demand for the end use cases of building all these models to justify the sprint in infrastructure build out that you could embark on?
Yeah, so let's frame the idea of what the infrastructure has to look like today versus what it looks like in the case of successful AI. Today, a company may need 16,000 GPUs to train a model. That's 16,000 GPUs. When the model is done, then they have to go serve it. I think that we're just starting to see what a successful AI product can look like with OpenAI. And if they need 16,000 GPUs to train the model, they may need 160,000 GPUs to serve the model, right? And that's what I think is very, very low penetration into like the end user market. As you have other people that find success and other applications that become successful, your scale there is probably orders of magnitude off, right? So do I think that the GPU cloud market today is way too small for what's coming 5 years down the road? Absolutely. But what does that 5-year path look like? I don't know, right? And we get this question all the time. It's like, how do you plan for something that has so much volatility and growth, and how does this market how does this market shape up over time? And it's probably the least sexy way to explain it, but it's really just like credit management.
Well, what is the risk that if the deployment of artificial intelligence into the real world doesn't happen at the pace at which it seems to be, that you end up with a glut of capacity?
I'd love that, because then I could buy it all.
Because you then would extrapolate and say, well, in 5 years' time, we'll
finally
get there.
It's dependent upon what your time horizon is, right? If your time horizon is 6 months and like the market takes a downturn, it's gonna take a downturn at some point in time. There's gonna be some softening in demand. Like some of these startups are gonna fail. Like it's gonna happen.
The VCs on the show would say 90% of them are going to fail.
Right? And if you look at the way that we've constructed our client portfolio, and we were talking about this in the green room, is that we've been able to be incredibly selective about who we work with.
We're talking about onboarding a new customer.
Yes.
So explain how that works and the sort of decision behind it.
Yeah. So we're a very different type of cloud provider. And people always ask, well, like, how are you different from DigitalOcean? I'm like, okay, well, DigitalOcean is built to serve 1 million people one instance. I'm built to serve one person 1 million instances, right? So when we take on new clients, we understand there's going to be an incredibly deep engineering relationship, like deeper than most of the clients expect, right? Is because we want for these people to be successful, like they need people holding their hands. We need their involvement in actually designing these things. So we almost go through a client interview process of like, okay, like tell me what this person said to that question. How did they answer this? How did they think about that? And we're not willing to take on people as clients right now that aren't going to be successful with us, because it's just we have limited resources and we have to make them count.
So do you then have to have competence on the software side to discern which of your customers?
We know very quickly.
But who do you have on roster in the staff that can help you do that?
I'm just the dumb infrastructure guy, right? And I have a VP of engineering who his name is Peter Solanki, and he's incredible. He is the single best technologist that I've ever met, and I've interacted with tons. And he learns things faster than anyone I've ever seen, and his ability to architect things on the fly is awesome. He's really architected and built a lot of our orchestration and workload management stuff that's become incredibly valuable to the market. He knows immediately. I've been through enough of these to know immediately. And then our onboarding and networking and all of our engineering teams, like they get involved very quickly, and it's okay. Like what type of customers are they going to be? Are they looking to do things the right way? Are they going to do things in a way that doesn't scale and we're going to have to spend tons of time on support with them? So there's a lot of intangibles that go into that early sales process of identifying, like, do we want these people?
We have a bit of extra time, but I actually wanted to offer the opportunity for any audience questions. How we could do it is if there's one or two of you that do want to ask a question, ask and I'll relay it, and we can go with that. Please, go ahead.
What's your basis for saying that the need to do serving would be 10x greater than training?
What is your basis for arguing that training would be, serving would be 10x what you currently do for training? Sorry, just for the mic's purposes.
Sure. So how many people in the world? Is it 7 billion people?
Let's go with 7, sure.
Or 7 billion people. Let's say that 3 billion of them are internet connected. Let's say that 10% of those are going to interact with an AI 5 years down the road on a daily basis. So that's 300 million people. Let's say that it takes this. I'm going to screw the math up here somewhere. 300 million people, takes 1 second per person to serve an AI request. That's 300 million people per day. 300 million seconds. That's a lot of seconds.
Mm-hmm.
How many seconds in a day?
I have the Bloomberg Terminal for all that stuff.
86,000. Okay, so 300 million divided by 86,000. Where are we there? So it's, yeah, this is getting too much. But, I screwed that one up.
You're basically...
The idea is you have 25 million people or so in the New York City metropolitan area, right? If 10% of those people want to interact with an AI at any point in time, and today the AI models will take 3 seconds to respond. That's so it's 250,000 people every second or every query, 3 seconds to respond. It means you need 750,000 GPUs to serve those to serve those people over that 3 second window, right? That's just for 250,000 people, or excuse me, 2.5 million people. Did I say 250,000?
Yes.
250,000 people, right? Like, that's bigger than the entire cloud scale GPU space today, right? That's just the New York City metropolitan market, right? Now, when you think about things like, okay, somebody's serving an ad campaign during an NFL game, and there's some recommendation engine or something that's going to power that, right? And now you have 50,000 people that are immediately hitting up an endpoint, has to be super localized because of low latency, and those GPUs just aren't there, right? So it's, how do you get GPU compute to that metropolitan edge? How do you do it quickly? And how do you do it in a way if you have volatility in what the demand profile looks like, right? So, I wish I had a better canned response to that one, but now I'm going to have one next time. But it's just a scale differential, right? It's very different, and it hasn't played out yet, or it's starting to play out with OpenAI, where they're governed in their ability to launch products by having capacity for GPUs.
Brian Venturo, I think we got more value out of that one audience question than I had anticipated. Mandeep, can I keep going? One more audience question?
One more.
Okay, let's go the gentleman at the back.
Talk to...
It has to be a relatively...
Easy question.
Yeah.
Super easy.
No math. Told you, I'm just a dumb infrastructure guy.
Could you talk to the efficiency gains that we are seeing from a compute perspective? And if we think about, the dollars spent per unit of compute over the past year, and then how do you frame what that efficiency will look like 5 years from now?
Efficiency gains through scale in the last year and over the course of the next decade.
Okay, so efficiency gains in the last year, I think it's somewhere between 3 and 4x for the same cost. I think that over the next 5 years, with the pace at which compute roadmaps are accelerating, it's probably an order of magnitude larger than that, right? And that's going to be from benefits of coherent memory spaces across GPUs, moving things like NVLink outside of a box and into a larger fabric in the rack. It's going to be newer, novel technologies that may not be changing the compute profile, but maybe unblocking around the periphery of that compute, right? So I think that we're just getting started on what creativity brings to solving some of these problems.
You just told Jensen Huang he has to redesign NVLink, kind of, and I didn't even get to ask this co-founder of a high-flying startup when he's going to IPO. So if anyone can get out of him in the drinks, I would be grateful.
I'm totally leaving before the drinks.
Just incredible conversation. Thank you very much, Brian Venturo.
Thank you.